Well, howdy y'all. This is my Magneto charger that I just finished building. It's got 1,000 turns of 10 gauge enamel wire on each coil there. The cores are 3-inch mild steel. Didn't have the money to pay for the Swedish soft iron, but this seems to work pretty good. 3-inch square at the bottom there, and machined up on the lathe, the 3-inch round there. With machined some holes, tapped some threads in there, but with the idea of bolting the like pole pieces that I've made at the top here, but it's more of a pain in the ass than it's worth, so I just sit them on there and it seems to work pretty good. So anyway, I've got like an ammeter there to try and get an idea of how much current, and we're looking for 65 amps because 1,000 turns, 65 amps is the magic 65,000 ampere turns and specified by Lucas for Magneto recharger. So we seem to get it. I've just picked up a peerless welder. It's got copper windings, and I run it on the higher voltage, which is actually the lower ampage rating, but the higher voltage carries the amps for the the length of copper with the 1,000 turns. Most people only make them out of 500 turns, but I wanted to try and get it up there so we're not putting so many amps for a thin bit of wire. But bit of a trial and error, and like I say, the length seems to hold the amps back, so maybe there's a bit of thought in the lesser turns. But either way, with the 70 volts going through it, it gets it up to 65 amps, just what I'm after. So it'll recharge any Magneto that you've got. Now I've hooked it up with some suppressor diodes. You see them there, and they're across the winding. So when you open the switch and the back EMF comes making a big spark, it shunts that power back through the diode and effectively protects the coils from a spark inside. Now I've got these in line, these big stud diodes, and they're protecting these little diodes, so if you plug it up the wrong way, you hook it up to get it backwards, you don't blow the diodes up. So they're just protection diodes, but I'll probably remove them later because I've bought myself a rectifier, 200 amp rectifier, which you need that because the welder puts out AC, and obviously we need DC to run these like a battery. And welders, yeah, the stick welder's AC. So anyway, we'll run it through this rectifier, and it turns it from in on this side, and then it converts it to DC and positive and negative, and then in she goes, right? So I can probably lose these diodes here, these ones anyway, not these ones because they're still for the switch when you open the switch. So I'll put the capacitor in there. You can see it, it's 50 volt, which is, even though it says 70 volts, it's only on for a few seconds, so it copes. And 47,000 microfarad is just what I had lying around. And I guess the bigger number that's probably it's more about how much amps it carries. So either way, I think the bigger one's probably going to be better, but it helps smooth the rectified wave out, so you get more closer to you know, DC like a battery. So anyway, it seems to give it more power, so that's the winner. I've got the knife switch there, but pretty much don't need to use it because I've just hit the switch on the welder and it's off, you know. I know a lot of people like to put a good switch on there because if you just got the little toggle switch, when you fire them up, there's so many amps that you can weld the contacts together on your switch. So having a knife switch, at least you know for sure that it's disconnected when you turn the power off. But I guess that only really matters if you're running off a battery or something. You'd use the switch because then you know, you don't want to burn your coils out leaving it turned on for a long time. So yeah, I just turned the welder off. So the finished job, thought I'd just show you with the fiberglass in place over the coils. Basically there to protect them. I've painted them black, so it's just basic fiberglass. Stops them getting bashed around, it weighs so much. And there's the rectifier nicely wired in. I got rid of the diodes that were protecting the smaller diodes because the rectifier pretty much is doing the same job. Anyway, there it is. Finished job. Good luck making your own.